So this video is to take you through the assignment that is practicing simplifying expressions and solving equations. So let's go ahead and get started. The first part of this assignment is asking you to distribute, right? And if you remember, distribute just means to take any number that's shoved up against your parentheses on the outside, right? And you are going to multiply it by all of your terms inside your parentheses. So this is saying I need to go through and I need to multiply 10 times x and then 10 times 6. Okay. So 10 times x is just 10x, right? You have x 10 times. 10x, and then you bring down your operation symbol, which is always going to be either an addition sign or a subtraction sign if we are doing distributive property. And then 10 times 6 is 60, right? Can I keep going? Can I combine 10x and 60? I cannot. I have to stop there because this has an x and this is just a constant. So that is as far as I can go with that. Okay. Keep going. Factor. Okay. So lots of kids are like, what does it mean by factoring? Factoring literally means you're going to turn the expression into a distributive problem. Okay. And the greatest common factor goes on the outside of your parentheses. Okay. So you're asking yourself, what number can go into 25 and into 10? Well, I know 5 can go into 25 and into 10. Okay. So now all I have to do is ask 5 times what gets me 25? 5 times 5 gets me 25, right? And then I see the addition sign. So I'm just going to use that. Don't even have to think about it, right? And then I say 5 times what is going to get me 10u. Well, I don't have a u over here, so I know I have to have a u here, right? I need 10u. Well, what gets me 10? 5 times what gets me 10? 5 times 2. And there's my u. So 5 times 2u will get me 10u. So notice factoring just means you're turning it into a distributive property problem. Okay. You're just working backwards. And the reason why they call it factoring is because you find the greatest number, the greatest factor that they have in common, and you use that. Okay. So let's try another one. I'm wondering if we can find another factoring problem. Oh, that's not one. I don't see one. Okay, let's just go through these and try. So if we have 8 C's and I subtract 5 C's from it, you are literally, oh my goodness, sorry, that's horrible. You're literally just taking 8 minus 5, right? And you get 3. I have 3 C's left, okay? Just going through as if they were whole numbers, right? Here's a distributive property, but notice that what you're distributing goes on the back, right? That's okay. You're just working from the other side now. So it just means 2 times V, 2V, right? 2 times V is 2V. The subtraction sign I just bring down, and then I need to do 2 times 4, which is 8. Right? So it's still multiplying. You're still distributing and multiplying to everything inside parentheses. You just happen to be going in the opposite direction. Okay. So it doesn't matter if it's shoved on the front or the back. This part really freaked some kids out because we had to go back and remember what it means to multiply by fractions. But once you get the hang of it and you kind of refresh your brain, I don't think it'll be too bad. So this, if you look, you're distributing a fraction, okay? Don't discount that. Don't say that you don't know how to do it. Let's try it, okay? So this means we have to take 1/5, right? And we're going to multiply it by 15. The main thing that you need to remember is anytime you're multiplying by a whole number, it's the same thing as putting it over 1, okay? We got to put it in fraction form. So if you remember, anytime you are multiplying by a whole number, it goes over 1 if you need it in fraction form, okay? I always go through and I cross simplify. So I'm saying I know 5 can go into 5 and into 15. So I'm going to simplify now. 5 can go into 5 one time. And 5 can go into 15 3 times. So now you get to just multiply across the top, right? And then I'm going to multiply across the bottom, and that gets me my answer. So my answer is going to be 1 times 3 is 3, and 1 times 1 is 1. And that is just a fancy fraction way of saying 3. Okay. So 1/5 times 15 gets me 3. And then I'm going to bring my addition sign down, right? And then the second part says 1/5 times 10. So let's try that. 1/5 times 10. So again, any whole number you have, you got to plop it over 1, right? And I'm going to cross simplify again because I know 5 can go into 5 and into 10. 5 will go into 5 once. 5 will go into 10 twice. So when I go through and I multiply this out, I end up with 2 over 1, which is the same thing as saying 2, right? So 1/5 times 10x is 2x, right? The x just kind of comes along with it. And I cannot keep going because this is a constant and this has an x. So I'm done. Let's see if I can find another one with fractions in it. Not yet. We'll come back to the fraction part, I guess. Okay, so here we go. Again, we're looking for just equivalent expressions. So if I go through and I say x plus x plus x plus x, that is 1, 2, 3, 4 x's. Yeah. It's not 4 plus x. It's I have x 4 times. So that's not true. Same thing here. I'm not adding x and 4, right? I have x 4 times. And then there's no subtraction going on here, so I don't know what that's all about. So that's definitely not one. Okay. What about okay. Over here, if we have 18y minus 12, okay, is this a different way to get this? If I take 6 times 3, do I get 18? I do. So 6 times 3y is 18y. If I take 6 times 2, do I get 12? I do. So this is actually another way of getting 18y minus 12. Okay. This, I mean, if I divided both of them by 2, I would get that, but that's not worth the same amount. So I'm not going to do that. 18y minus 12. If they said 6y, all they did was go through and subtract those two, and you can't subtract them because this has a y and this doesn't. So I can't go any further. I'm not going to get 6y. And then this part right here is actually just writing it out. 6 times 3y, 6 times 3y, and then 6 times 2, 6 times 2. So this way, this is just the longer written out version of the distribution process here. Okay. Yay. All right, one more. These sound tricky at the beginning, but they're really not. Basically, it's just saying, hey, I'm going to give you a couple of different numbers, and I want you to plug them in where you see you. Okay. So this is saying, 46 equals 37 plus u. Okay. So in this case, instead of putting a u, I'm going to put 83. And then you just ask yourself, 37 plus 83, is that equal to 46? Hopefully, you guys can see that it's not, right? Without even going any further. Okay. What about 6? So if I just subtract this out, or sorry, if I erase this part, right? Instead of putting 83 there, I'm going to put the number 6 because that's what I'm moving on to, right? 6 where u goes. So I'm going to put this right here. 37 plus 6. Is that going to get me 46? Nope, it's not, right? So again, this is just you kind of plugging in and going, right? So I'm going to put no, a new. What if I put an 11 there instead, right? 37 plus 11, give me 48. So that's a no, right? No. And then what about 9? What do you think? A 9? 37 plus 9. And don't assume that because the first 3 were no's, that the last one has to be a yes, because that's not always going to be the case. I have seen them all be no's, and they've, that might just happen. But in this case, it is actually true. Okay, so yes, 37 plus 9 will get you 46. So on this one, it is a solution. It does actually make a true statement. So notice all you do is whatever value they give you, you plug in, solve, and see if it makes a true statement or not. That's all you're doing. Okie doke. Okay. Hmm. And let's see here. Next part. Okay, solve for you, same thing. Okay, so this part is where I have talked to you guys about how you need Dorito math. Okay, Dorito math by using inverse operations. Inverse operations are the opposite. Okay, so if you look right now, here's my original problem. 2 plus u equals 11, right? Okay. So technically I can go through and I can say I have a positive 2 here, right? I'm going to subtract 2 from it instead, okay? So if you have 2 and you take 2 away, it just leaves you with u on that side, right? It made it cancel out. It made it go away. That's the opposite operation, or inverse, right? I had a positive 2, then I took 2 away. So it cancels out and it leaves you with just u. But whatever you do to one side, you have to do to the other, okay? So that's where you end up getting somewhat of a Dorito style. This is what I mean by being able to show your work, okay? So I'm going to show you another one just to kind of walk you through it, okay? So here's a different style. And if you look on here, guys, this line, it is a fraction, but basically this means you have a variable and you're dividing it by 4, right? And whatever number that is, when you divide it by 4, it should equal 92. So it's not the fact that you know what it is. You have to show your work correctly in order to pass this section, okay? Because I need for you to show your work. So when things get more difficult, you know how to go about doing it, okay? So you find your variable. My variable is x. Figure out what's being done to it. Right now, I'm dividing by 4. What's the opposite of that? What's the inverse operation for dividing by 4? Well, the opposite would be to multiply by 4. Okay, that helps cancel that whole process out and leave me with just x. Okay, so if I multiply this side by 4 to get x isolated, then I'm going to multiply this side by 4. Okay, because whatever you do to one side, you have to do to the other. So I'm taking 92 and I'm multiplying it by 4. That is what I need to go through and enter as my answer. Okay, x equals 368. Okay, one last one here. We have, again, something that I feel like you should be able to answer right off the bat. It's not about your answer, right? If you just give me the answer on your test, you will have to repeat the unit, okay? It's not about the answer. Hopefully you can just look at this and know, okay? Instead, we're looking for you to solve using the correct format. Find your variable, W. What's being done to your variable? We're adding 7. What's the opposite of that? What's the inverse operation? The opposite would be to subtract 7. And whatever you do to one side to cancel out, because you want your variable isolated all by itself, right? So you can figure out what the answer is. Whatever you do to one side, you have to do to the other. So if I subtract it over there, I have to subtract 7 over here. And that is how you show your work. Yes, we probably all knew it was 3 right off the bat, but this is how you show your work in algebra. Okay, so we're getting comfortable with that. Let's see if we have one more. Oh, this one is let's not do this right now. We'll do that one next. See if I have any others. I think I did all of them, didn't I? I think that's it, you guys. Okay. So when we're talking about inverse operations, you are saying the opposite of multiplying is going to be dividing, right? And the opposite of adding is subtracting, or the inverse operation. Okay, so if you see one of these, to undo it, you do the opposite or the inverse. Okay, so these go hand in hand. And we'll keep practicing that, but that's a really good start.